Hi, my name is Rong Lu, and I'm a program manager on the Visual C++ team. It is increasingly more common to see user interfaces for modern apps that are graphically intensive. Whether you are using DirectX to develop 3D games or graphically intensive apps, Visual Studio has a wide range of tools that offer to make your jobs a little bit easier. In this session, we're going to take a tour of what's new in Visual Studio 2013 for building store apps using DirectX. Now let me walk you through a couple of features we added in Visual Studio 2013 to help you build DirectX application. Let's start with project template. In the previous version of Visual Studio, we provided two DirectX app templates. Now in Visual Studio 2013, we refreshed those two templates and make them better in a couple of ways. To start off, these two templates we have here in the new release are called DirectX app and DirectX app that can interact with XAML. First of all, they are appropriately named, meaning that both are DirectX apps that you can use Direct 3D and 2D at the same time. Now let me start with one of those, and I'll show you the code. Now this is the generated project, and this is your main file. If you scroll down, you will see update, render. You will know that this is where we also added to do to help you locate where you should insert your custom code. The other thing we did was to restructure the whole project so that it's easier to understand where you should get started. Now let me expand those files. First of all, we put all the common initialization code in a common folder. So if you don't want to touch them, you can just leave them there. We added a content folder, which all the sample code goes into. We also appropriately named all the files starting with sample, so you know these are the files that you should go and replace to start your building your DirectX applications. Let me run this real quick. I'll show you what it does. It's pretty straightforward and simple. It does basically the same thing it did last time. It is a 3D rotating cube. What you will notice is this time around we added a frame rate text to the default template, so you don't have to figure out that by yourself. Go back. Now if we look at this code, it makes more sense now. First of all, we had this 3D scene renderer that does the rendering of this 3D cube. And then we have this FPX text renderer, which does the rendering for this text. And then we had a couple of sample shader files. So these are the places where you should go ahead and replace with your own code. The other thing we did with the templates was we structured in a way so that the DirectX native app and the DirectX XAML app are very similarly structured, making it very easy to transit from one to the other if you desire. The other thing I want to show you is a sample solution that we shipped earlier, which is called 3D Starter Kit. Now, this time we actually refreshed that sample code as well. If we go to online, you can get the sample this way. It's shipped on MSDN. And if you go to sample and search for 3D Starter Kit, this is the Visual Studio 3D Starter Kit. This was designed for two purposes. One, you can use it for learning purposes if you are just getting started with DirectX. Two, you can also take this as a starting point for building your own DirectX application. Now I have this open. I just want to run this real quick for you. This uses a couple of models, and there's animation and there's textures applied. There's lighting effects using shaders. It's all in there. So it is a great tool for you to go and take a look at those and learn about DirectX applications if you want. It is also refreshed such a way that it is now structured very similarly to the new template. So you can compare those two solutions and learn about the differences and how it works with different models. We have models here, textures, and shaders. Next thing I want to show you is our graphics diagnostics tool. As soon as you start building your DirectX applications, you're going to need a debugger to identify your rendering issues, if there's any. You notice there might be an object missing, it's not rendering correct in the correct color. All those sorts of things can be identified using our graphics diagnostics tool. Now, in the previous version of Visual Studio, we support debugging DirectX applications that run on your local box or in a simulator. Now, what we added in this release was it now supports debugging apps that run on remote devices. So I'm going to show you a quick demo of that. So I have a different application here. So what I did was I set up the properties. And in the debugging session, I set up to use a remote machine. I identify the name. And that's pretty much all you need to do to start debugging on remote devices. Now, on the other device I have, which is a Surface device, I have my remote debugging tool here. Now it's ready to take connections. Now go back to my main machine. I'm going to launch this with our graphics diagnostics tool. I go to debug menu, graphics, and say start diagnostics. Now this is actually being launched on my remote machine, which is my Surface. Here it says press print screen to capture frame. This is actually how you are going to use this tool to diagnose your DirectX applications. You capture a frame and you go back to Visual Studio to inspect all the information it captured for you. All right, we got the image back. So Visual Studio actually went and grabbed all the DirectX events from your local machine and sent all those information back to my local box. Now this is one frame I captured. I can continue to capture multiple frames. I can stop debugging to start analyze this frame. On the right side, we have an event list that shows you all the DirectX events that happened during that frame. I can also do a filtering. For example, here, I looked up all the draw events. The other thing I can look at is if I select a particular pixel, I can look at the pixel history, looking at all the DirectX events that are associated with this particular pixel. I can expand each event. I can look at the different shaders that is used. I can also start shader debugging right from here. Now notice this is captured from my remote machine. And while I am analyzing all this information, this is also playing back on my remote machine. Notice this here. This is saying I am playing back on the remote device. Now, what's cool about this new feature is you can now save this log file to your disk. You can open that later, and you can play back on any machine you want. For example, I can play back on my local machine in this case, if I want to play it and try different hardware. Now this is using my local machine to play back. You can also share this file with your colleagues, and they will be able to play back on their machine. In Graphics Diagnostics tool, we also added two more features that support new DirectX features. The first of them is compute shader debugging support. As I said, in the previous version, you can debug various types of shaders, such as pixel shader, vertex shader, etc. In Visual Studio 2013, we added support for debugging compute shaders written in HLSL. Compute shader is a programmable shader stage that expands Direct3D 11 beyond graphics programming. It provides high-speed, general-purpose computing and takes advantage of the large numbers of parallel processors on the GPU. compute shader can run on many threads in parallel. Let me show you an example of that. Here I have this application, which basically simulates the movement of particles. And as it moves around, it will bounce back if it hit the side, hit the boundary. And it also takes gravity into consideration when it calculates the acceleration and velocity. Now, this is a complete computation scenario. But in this case, it is leveraging the compute shader feature in Direct 3D, and it's rendering using DirectX actually. Now, I have previously captured a couple of frames. Now, what we can see on the right side is, again, the event list. So what we are interested in this case is dispatch calls, because this is what you're going to use to execute compute shaders. So we do a filter, and we can navigate around by clicking on different calls. Now, when I select one of these dispatch calls, the pipeline stage window shows up. This is where you can start debugging your compute shaders. First of all, we show you different thread groups and threads. It identified how many threads you used in your applications. And I can type in any number within that range and say start debugging right from there. Now what it does is it generates traces, and in this case it opens the HLSL file for me and locate this compute shader code I have. Notice this is HLSL code. Now, just as you would expect, now you can do debugging, actually going through the code line by line. I can do a step over. Notice here in the autos window, you will see all the value changes of your variables. Now I can hover over to see the value as well. I can go ahead and continue debugging this, just like you would do with any code debugging. The second feature I want to show you is the support for deferred context. Direct 3D 11 supports two types of rendering, immediate and deferred. Immediate rendering queues graphics commands in the command buffer and execute on the GPU immediately. On the other hand, deferred rendering is a new concept in D3D 11. It is designed to support rendering on one thread while recording commands for rendering on additional threads. This parallel multi-thread strategy allows you to break up complex scenes into concurrent tasks. Now, let me show you an example of that and how you can use the debugger to debug apps that use deferred context. Here I have a different app. This one leverages the deferred context concept. Now this is pretty straightforward. Basically what I do is I render different colors of quad on the screen. Now in this case, I filtered my event list by just showing draw calls and my commands. I can do this, and this list is filtered now down to these. First of all, I draw a purple quad. This is actually using immediate context, just for comparison. The second draw I make is I want to draw an orange quad. This is using deferred context. Now let's walk through this list and see how different they are. Now notice when I click on the draw, this purple quad is being drawn. And the pipeline stage actually showed different stages for this quad. And if I walk through the next one, which is draw orange quad, notice when I click on draw, the orange quad is not being drawn. This is because I am using a deferred context for this command to be executed later. Now, our graphics diagnostics tool works with this great because it tells you, okay, when I select this one, it says pipeline stage are not computable for deferred context because we know it is using deferred context. And then you should examine the children of execute. That is when the commands are actually being executed. So I walk through that. I'm going over here and notice there's another jaw under execute. In this case, when I select this jaw, the orange quad shows up, which means this is when the actual command is being executed. And our pipeline stage also works correctly, showing up that status. So this is how you can use our diagnostics tool to work with your apps that use deferred context. Visual Studio 2013 makes it even easier to building store apps using DirectX. In addition to the existing asset design and build content pipeline tools in the previous Visual Studio release, Visual Studio 2013 provides refreshed DirectX app project templates, 3D starter kit to get you started, and a more powerful graphics diagnostics tool that extends the support for more scenarios. Whether you are using deferred context, compute shaders, or working with remote devices, you can use this tool to identify rendering issues in your app. Hopefully you like all these new features in this release of Visual Studio, and thank you for watching this.